you're able to either pause this, jump to another slide with your your menu on the right-hand side, or you can also fast forward. Okay, so this is the absolute value function. The basic one, f of x is equal to the absolute value of x. Now remember, absolute values leave positive numbers positive, and if it's a negative number, it changes it to a positive number because it represents distance, and we can never have a negative distance. That's where absolute value comes from. We are going to talk about the basic function. Its graph looks like this. Notice it's V-shaped. It's very distinctive. Anytime you see an absolute value function, most likely, unless it's one of those crazy ones, most likely it'll be shaped like a V. It may be an upside down V, but it will be a V shape of some type. Now for our basic absolute value function, the zeros, which you may be asking, what are zeros? Zeros are the numbers x that make f of x equal 0. So anytime you're asked to find the zeros, you change f of x to 0, set it equal to the other side of the equation, and then you solve that. Well, for this one, we take off the absolute values and just get x equals 0. Okay, the x values where you have your x-intercept, those are also considered zeros. Okay, that's the x-coordinate of your x-intercept is your 0. X-intercepts, what are intercept means to come in contact with. X means the x-axis. So this is the point or points where the graph of the function touches the x-axis. We can see that that happens at the point 0, 0. The y-intercept, this does not happen very often, but it does in this graph, is the same. Y-intercept is the point on the function where it touches the y-axis. And once again, that is the point 0, 0. The domain is our x values. So if we look at absolute value x, our function, what can we put in for x? Are there any restrictions? And there are not. So our domain is all real numbers. Another way of writing that is with interval notation. What this means is all numbers from negative infinity to infinity. Again, all real numbers. The range is the y values for our function. And if we look at this graph, where do we have y values? Well, we start at 0 and we go up from 0 for our y values. Notice we don't have any negative y values. Okay? So our range, the y values we actually have in this case, start at 0, including it. That's why I have the square bracket here, and going to infinity. You could also write that as all y's greater than or equal to 0. Okay? That's our range. Intervals where the function is decreasing. Now, if a function is decreasing, that indicates that it is going downward as you travel to the right. So the section of the graph where our line is going downward is here. Okay? Notice then it stops and heads upward as we go to the right, just the same way you read a book, left to right. Okay, going down, we can't see the starting point where that happens. We have an arrow, which means it goes forever in that direction. So our interval of decreasing is from negative infinity to 0. That's its stopping point where it changes direction. Interval increasing would be places where the graph is going upward to the right. And when they ask for interval, you want the x values where this is happening. Okay, not the y values, but the x values. So this is our increasing part of the function. And if I look down here, the x values where that is happening starts at 0 and goes on forever, so goes to infinity. Again, you could write these with greater than, less than signs. The interval decreasing would be all x values less than or equal to 0. Just less than 0 and x greater than 0. Okay. The minimum value is the lowest point on the graph. You don't always have a minimum value. In this case, we do, however. I'm going to go ahead and erase. So if you need to take notes, pause this for a second and write those things down. But I'm going to go ahead and erase my screen so I can see a little better. Okay. I have this absolute value function. I do have a minimum value right here. That's the lowest point on the graph. There's nothing lower than that. So my minimum is at the point 0, 0. A maximum for the function would be a highest point on the graph. And notice these arrows continue upward forever, so I don't have a maximum. So this is just our basic absolute value function. What we're going to be doing now is we are going to be graphing that using transformations, which you learned in a previous lesson, as far as what happens to a function when you add values inside and outside of the function. Okay, so let's review transformations really quickly. Horizontal changes for this absolute value of x will be anything that's inside the absolute value symbol. That is our function. So horizontal, or changes left and right, okay, or changes to our x value, will be anything that happens inside of this absolute value, okay? There's a few things that could happen. One thing is that we could add a number inside of there. If I have the absolute value of x plus 3, one thing I want you to remember is because of the solutions and solving for things, anything that happens inside here is opposite of what we would think. When we graph a point, plus 3 means we go to the right. What it's actually going to do to the graph is move it to the left 3. So my new graph, it would subtract 3 from all of my y values. So my 0, 0 would move 3 to the left and would be here instead. My 1, 1, if I subtract 3 from my 1 here, I get negative 2, 1. And my negative 1, negative 1, if I subtract 3 from that x value, I get negative 4, 1. Okay. Nothing else has changed. I haven't multiplied by anything, so nothing else has changed, only the location of that v. It goes up at exactly the same rate, only now it's 3 to the left of where it was originally. Okay, so remember, adding inside the function moves it to the left. I'm going to erase now, so if you need to write things down, go ahead and do that and pause it. Another thing we could do is, rather than adding, we could subtract. Let's say I did x minus 2. Again, anything inside of this affects your x value, and it affects it the opposite of what you would think. A minus, normally when we graph, we go to the left for minus, but it's going to take us 2 to the right. It's going to add 2 to all of our x values. So instead of at 0, 0, my bottom point here would be at 2, 0, and my other 2 points would be here and here. I've just moved the entire v to the left 2. Okay? Notice now my minimum is different. My minimum value is at 2, 0 now. My intervals for decreasing are from negative infinity to 2 and increasing from 2 to infinity. My range is still the same. My y values are still all up from here, from 0. Okay, so my range would be from 0 to infinity still, but a few things have changed. Okay, I'm going to erase once again. We're going to talk about some things that can happen vertically. Now, vertically would be anything that happens outside of that absolute value symbol. Okay, so let's say I had a function g of x, and it was the absolute value of x plus 4. Anything that happens outside is going to affect my y values vertically, up and down. A plus 4 would move my graph up 4, or add 4 to all of my y values. So now my 0, 0 is up 4. My 1, 1, I add 4 to my y values. Again, anything outside changes your y values. Okay, my negative 1, 1 would be at negative 1, 5 up here. Okay, so I've just taken that v and I've moved it up 5. in green here, rather than erasing, let's say I had h of x, which was the absolute value of x minus 1. Again, anything outside of the symbol affects your y. Negative is going to move it down 1. So here's my new point, here, here, and here. Okay, and there's my new graph. Another thing that can happen is, let's call this one p of x. We'll make it red. Let's say we have 2 multiplied in front of the absolute value. What that's going to do, again, is outside, so it's going to change my y values. It's going to multiply each y value by 2. It's going to make it 2 times as steep for the size of my function. So I have this point 0, 0 is not going to change because 0 times 2 is still 0. My 1, 1, again, this is the y values that are changing. So I'm going to multiply that by 2, and I get the point 1, 2. So you can see what happened is the slope of my line, instead of being 1 here, is a slope of 2. My negative 1, 1 over on the other side. Again, this changes my y value by a factor of 2. So now I am at negative 1, 2. And there you go. So those are some things that can happen. One more that's very important that may come up. I'm going to go ahead and erase. So pause if you need to. One more thing that could happen is that I could have, for example, g of x is equal to negative 2 times the absolute value of x. What a negative is going to do is it reflects over the x-axis or flips the graph upside down. So now our v will be going down instead of up, and we will have a maximum value rather than a minimum value. What our new graph would look like, again, this changes our y values by a factor of negative 2. So I would multiply the y's by negative 2 to figure out what would happen here. My 0 would stay at 0, 0. But my 1, 1 would change to 1, negative 2. So it's twice as steep, and it's going upside down. Okay, this is what my new graph would look like. Right, so those are some of the transformations that can happen based on our rules of transformation.